Last time we left off at the manual discovery framework stack for the content discovery machine or scenario here on TryHackMe, and this is actually part of the junior penetration test learning path, which they say it's an intermediate path and actually takes 56 hours to complete. I'm not really sure if this is intermediate because so far I've seen sort of like I have mixed feelings when it comes to the level at which you should be when completing this. But anyways, the remainder that's for this scenario, if we look over one more time at the junior penetration tester path, there's been introduction to pen testing, which was mostly theoretical and uninteresting, and then we went into introduction to web hacking, and this is where we are at the moment. So there's a lot of stuff to go through in the coming videos. I'm really excited to see what the burp suite sort of like sub path of the learning path is all about. Network security might be interesting. I'm seeing a lot of Nmap here, which is uninteresting. Vulnerability research, we'll see. Metasploit, I don't like it. I don't use it a lot in my penetration tests, but anyways. Privilege escalation, I don't use it. I mean, privilege escalation, I find it's a lot in CTF-ish stuff on websites like where you have to own a machine entirely, which is most often not the case when you have to do a penetration test. You do not need to escalate your privileges to full account takeover or full admin or full machine, full ownership. Most often than not for penetration testers, these are unrealistic scenarios. But anyways, I might just be one of them who's actually not been confronted with such scenarios. In any case, let's get back to where we were at content discovery. So the first 6 tasks have been done in the previous video, and I like to remind you that I've created a playlist on my YouTube channel which is called Junior Penetration Tester Learning Path, and I've added all the 4 videos so far. Content Discovery Part 1, which was the previous one, and this one is going to be Content Discovery Part 2. Let me make sure that I'm actually recording here, not speaking by myself. So 2 minutes in. I would like to keep it similar to previous videos where I wouldn't go beyond 25 minutes just for YouTube optimization purposes. So I'm not really sure if I'm gonna finish the entire 12 tasks, the remaining 6 tasks from 7 to 12 in this video. But anyways, there's always room, or there's always the next video, which is why do share this video everywhere, because I'm not getting anything out of it. This is actually what I'm doing here is on my free time, so there is no incentive behind it unless you're actually sharing or showing your support for these videos, which is actually what's going to motivate me to go on and keep doing that. Now, I've kind of spent 3 minutes, 4 minutes talking about introductory stuff or like housekeeping stuff. So let's get into it. OSINT, Google hacking, dorking. Well, I would like to say that when you deal with a very large company, for example, there might be situations in generic penetration tests, for example, and in these videos I'm actually going to be talking about penetration testing. I'm not going to be talking about bug bounty hunting. I'm only going to be talking about bug bounty hunting here and there just for comparison purposes, because I'm not really interested at this moment in bug bounty hunting, as I've said in previous videos, because it's a very unstable source of income and can lead to big frustrations. I'm all for in penetration tests, stable source of income, direct contact with the developers and all that stuff. So when you're doing a penetration test, it's highly unlikely that you're going to receive a very large application, for example, say, or a very large target, say Tesla.com, like you would do in a bug bounty hunting scenario. So in that case, when you're dealing with small companies, small web applications that you have to penetration test, Google hacking isn't going to do you a lot of service. Let's be honest. I'm not going to find a lot of stuff on Google on like a very new company or a startup, which is why this doesn't make sense. But oftentimes you have to know how to search via Google Dorks, which is why, for example, if Google indexes, and in this case, it might be useful regardless of the target that you're dealing with. So, for example, let's say you're dealing with XYZ target, and you could just simply do site xyz.com, and this is actually going to give you everything that Google has on this target based on, as we've seen in previous videos, based on the robots.txt, based on the contents of the robots.txt, and also based on the sitemap.xml if it exists. So in that case, you're going to find what Google is allowed. You could combine dorks, for example, the site with the in URL to be more accurate. You could also look for file types. And of course, as you can see, more information on Google hacking. To be honest, I use it in penetration tests almost 0 times. So that's that. More information about Google hacking can be found on Google hacking and also in GHDB, Google hacking database, which is where you'll find the full index of all the 7,341 Google entries. I have some of them here myself. If I can filter for, let's say, author myself, I have 3 Google Dorks, which are somewhat uninteresting. Regardless, what Google Dork operator can be used to only show results from a particular site? So that's actually site. With the colon. Okay. Moving on to task number 8, Webalizer. And I've talked about Webalizer. I believe it was the previous video when I said that one of the extensions that I'm using in Chrome, which is also available in Firefox as far as I know, is the Webalizer, which actually tells you the technologies that are powering the website or the tab that you're currently at. Now in this case we are at tryhackme.com. We can see that they use Hotjar and Google Analytics for their analytics. How does Webalizer know that? We could simply look into the source code in this case, and you probably have someplace here where is the GA, for example, the Google Analytics. The Google Analytics tracking code within a script, usually at the bottom or at the top. It's not here. If we look at the top, you can see that they're also using Amazon AWS. Let's find where the script for Google Analytics is. They should have a code, a tracking code that's actually used in the Google Analytics dashboard. Or at least that's how it usually works. It's not in there. They have the CSRF token. If we look for Google, they have the Google Tag Manager. It might be somewhere hidden over here. What else? does Webalizer tell us? Talks about Hotjar. Let's see if we look for Hotjar. So there you have it, the Hotjar in the source of the page. This is actually how they know what the website is powered by. There's a lot of stuff in here, so you could just go down the rabbit hole by simply looking into the source code or using something as Wapalizer, for example, with plus company and contact details of website are shown here. Not really sure if this is very useful though. So JavaScript frameworks, they use React and Socket.io, they use video players, web frameworks, Express, JavaScript graphics, and if any of these technologies have some sort of vulnerabilities, you can further increase the attack surface just by knowing what's powering the website. Google Tag Manager, we've seen that in the source code, the libraries, jQuery, BAAS, what is it? It's not product as a service, but platform as a service. Amazon Web Services, they use Amazon load balancing, and we've seen that they use the S3, for example, for their user avatar. So if we go ahead and look at this, you can see this is my avatar, and you probably, this is actually very intuitive because you've seen that my username is Christy here. You cannot actually see it, but my username is Christy. So if we look for other usernames, let's say John, for example, you can see you can just base. Now, if this weren't to be configured properly, you would have access to all user avatars. But in this case, if you try to access the user avatars folder, you're just it's downloading something. If we try to access it via the JSON, you have the access denied. If you try to access the entire bucket, you also have the access denied. So they set up, at a first glance, they set up their permissions appropriately here. Now, what online tool can be used to identify what technologies a website is running? Wapalizer, Wayback Machine. Alright, so there's a lot to say about Wayback Machine. Let me make sure we're still on time here. 30 minutes. Alright, we might get this completed. So I'm actually using Wayback Machine whenever and for the very little time that I'm doing bug bounty hunting on Synack, for example. And how I'm using Wayback Machine is part of a script that actually gets. And what I want to say is that I'm not only using the Wayback Machine, but I'm also using something called Wayback Robots. So Wayback Robots, do look it out or look it up if you're interested in cybersecurity research. It's actually going to use Wayback Machine to look historically over for all the robots files, robots.txt files of a certain asset that have been or that have existed at any point in time for a certain web asset. And what is it going to do is what my script actually takes all the found robots.txt and it actually combines the relative path found in those robots.txt for both allowed and disallowed, I believe. I'm not actually going to share this, so don't ask for it. But you can build it yourself if you follow me, if you follow what I'm saying here. So it actually combines the asset or the URL of the asset that I'm talking about with the relative path that is found in the historical robots.txt file. So if you're smart, you can simply just use Bash or Python to actually build that kind of script. I'm actually using that, so it's powered. The Wayback Robots is powered by Wayback Machine. Wayback Machine is a really useful tool for someone who's doing large-scale cybersecurity research. When you have an asset and you use Wayback Machine, either by using, for example, the tool by Tom Nom Nom, which was, what was it called? Something with way, something with way in it. So Tom Nom Nom Wayback URLs. So Wayback URLs, but I'm not actually using Wayback URLs. I believe I'm using Gal Plus, because I'm actually not interested. I'm actually filtering for image extensions and some other stuff that Gal Plus is optimized. So the Wayback Machine actually is a historical archive of a website that dates back to the late 90s. You can search a domain name and it will show you all the times the service scrapped the web page and saved the contents. This service can help uncover all pages that may still be active on the current website. Really important, and I've found some gems over the years using the Wayback Machine and all the tools that are powered by the Wayback Machine. What is the website address for Wayback Machine? So it's probably be https archive.org slash something with time. Let's see. Wayback Machine archive.org slash web. Is it? It is. Alrighty, GitHub. Now, to keep on the same, not necessarily premise, but the idea or argument with the Google hacking or dorking, you might do open source intelligence on GitHub, most specifically when you have large targets. If you're dealing with a small website, a small web application, a small company, there isn't going to be much to be found when it comes to open source intelligence on GitHub, because if the company is not actually producing open source software, or if the company isn't actually a very large one with a lot of code on GitHub, there's not much into it. But for example, if you're dealing with the company, if you're doing cybersecurity research on Google and you look up their page on GitHub, you can see that they have 2200 repositories. This actually makes sense for open source intelligence when you're talking about a very large company, and everything for that matter is in scope when it comes to cybersecurity research. So if you require a large target to actually find stuff on it, and I found some very interesting stuff on their Google bug bounty hunting program, you can just look up Google and like mindlessly scroll through all the repositories here, and instead of just using like search operators such as to find vulnerable information like API keys and all that stuff, I would actually encourage you to start reading the code, because this way you're not only actually going to be able to find something that not other people are finding. So if you actually read the code and you understand the code, first of all, to be able to read the code, you need to understand the code. So I would suggest, if you want to get into secure code review, you do not necessarily actually have to be a full stack developer, but you have to understand what code does, like generically or broadly speaking. Because if you understand what code does, you do not necessarily have to understand the entire syntax or everything for that matter. But if you understand what code does, you'd actually be able to find flaws that people who are searching for API keys are not going to find. That's actually a very good point that I had to make. Not only that, but if you start reading code on a daily basis, not only code that you find on GitHub, but also source code such as JS files, in time you might get very good at it. Not necessarily you might, but you very likely will get very good at it just by the nature of repeating something. So you might be able to tap into an area of cybersecurity research that most people don't tap, especially in the world today. In today's world, when everybody is trying to use automation and try to automate every step of the process, if you're actually doing manual stuff, you can get far, far further than other people. So, getting back to my main idea, OSINT on GitHub is only going to make sense when you're dealing with a large company or a target, or in some situations, it could also be a smaller company that has their code in private repositories, and that's not only applicable to GitHub but also to Bitbucket, to Gist, and also to other repository systems that are out there. So to understand GitHub, you first need to understand Git. Git is a version control system that tracks changes to files in a project. Blah 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 blah. When users have finished making their changes, they commit them with the message and then push them back to a central location to the repository for the other users to pull those changes to their local machines. Now, GitHub is a hosted version of Git. So what actually powers GitHub is Git. Repositories can either be set to public or private and have various access controls. You can use GitHub's search function feature to look for company names or website names to try to locate repositories belonging to your target. Once discovered, you may have access to source code, passwords, or other content that you hadn't found yet. Again, I would not necessarily focus on sensitive information in code because GitHub in of itself has set in place different mechanisms. Not only GitHub but other companies such as Amazon have set in place mechanisms to prevent leak of credentials to happen, and they are more rare nowadays. Even though you can still find them, I wouldn't focus on that. I wouldn't focus on finding sensitive information in source code, especially API keys or passwords that are hosted on GitHub or other private and public repositories. Instead, like I said, I would focus on reading the code and actually trying to find flaws in the logic of the code. What is Git? It's a version control system, and you have that especially bolded in there. S3 buckets. This gets interesting. 22 minutes. So S3 buckets are a storage service provided by Amazon AWS, Amazon Web Services. And as I've shown you, we've got the images S3. What was it? Try hack me. Images S3. This is what they're talking about. Allowing people to save files and even static website content in the cloud accessible over HTTP. The owner of the files can set permissions. This is really important. So in this case, we're only talking about reading permissions. When you're testing storage and S3 buckets, you have the command line interface for Amazon, which is AWS. You can install that. I don't think I have it installed. Do I? I do have it installed on Windows here, but I actually have it installed on my VPS. And I'm actually using AWS S3, for example, ls, to look into a certain repository. In this case, it would be try hack me images. Maybe that's how you call it. Let's see. I'm not even sure. Unable to locate credentials. So I haven't configured AWS, but that's how you actually run it on a certain web bucket. In this case, it would be to actually check for permissions more thoroughly. You can do, instead of listing, you can copy something from, let's say, this.txt into a certain S3 bucket, and you would actually check if there is copy permission. And you can also copy the other way around, so from the S3 into your local. You can also remove, I believe it's RM or del, and there might be others, but these are the ones that I'm actually testing for when I'm dealing with testing S3 buckets. So the format is the name.s3.amazonaws.com. Now in this case, we've seen that we can access the user avatars like that, but we could also just like get this. So S3 Amazon and then try hack me. We could also access it in a different way, I believe, using the specified please send all future requests to this endpoint. So they're actually, you could also oftentimes you can access an S3 bucket by going straight to s3amazon.com. You might actually have to specify the region, maybe, and then you forward slash the bucket name and then whatever resource it is in that bucket. So this is a permanent redirect. It often is not. S3 buckets can be discovered in many ways. There are many tools. I don't actually focus on doing S3 bucket hunting. I used to do that in the past using different tools for S3 buckets when I was dealing with large targets or when I was actually doing public bug bounty hunting, for example, like bug bounty hunting on public or public assets like Tesla, for example. What URL format do Amazon S3 buckets end in? So you have .s3.amazonaws.com. All right, automated discovery. There's a lot to be saying on automation here. Automated discovery is the process of using tools to discover content rather than doing it manually. So if you're doing cybersecurity research for a company, or specifically if you're doing it independently on a certain platform, automated discovery is often very helpful. And to be able to have some edge when it comes to automated discovery, I would actually encourage you to write your own tools, which is what I did myself. So I have my own private tools. When I get the bug in me to actually do some large scale automation, I just take a target from my private invites and I just run all the tools that I have written myself. Word lists. So you have the tools, then you have the word lists that are actually powering the tools, and depending on the type of testing that you're doing, or depending on the tactic that you're applying, or depending on the scope that you're actually looking for or playing within, you might have a word list. For example, you would not have a word list when you're actually testing. You would not have the same word list when you're testing for input validation versus when you're testing for password strength. Automation tools. Exactly what I was saying. On the attacker box, execute the following 3 commands targeting the Acme IT support website. See what results you get. So this actually means that I have to start the attack box. Jeez, it's gonna take, this video is actually gonna take longer than expected. So, what is the name of directory beginning with mo? Could we guess it without actually doing this? /mobile / what? What could it be? What's the name of the log file that was discovered? So we actually have to do it. Waiting for the machine to initialize. So this is a free room, which means anyone can deploy virtual machines. So we're gonna actually kill some time here. 33,900 people are in here, and this room is 207 days old. So it's been actually created quite recently. Our IP machine is 10.10.154.43. What could it be? What could it be? The mo. It's not mobile. It's not 73, 74, 75. Just a little bit more time. Would this be an error log file? Come on. So I'm actually doing these videos, I'm actually recording these videos without any edits. So these videos are just recording and going onto YouTube because given the little amount of time that I have, and given the fact that I'm doing this actually for free, I wouldn't have any motivation to start editing these videos professionally because YouTube is not actually what I'm doing full time. One of the things that puts money on the table in this case for me is penetration testing, so that's actually what I'm focusing part of my time on. What was it? 10.10.1. Forgot it. 154.43. Interesting. Why? Let's actually do something here. We're looking for status code. What was it, the status code for FUF grep status MC? So we're actually looking for MC200. I don't want to see the progress. So interesting. Maybe it isn't. Maybe it's. Let's not specify anything. How do you suppress? What is the name of the directory beginning with mo? We could simply say grep mo. How do you suppress the progress? I think we had something over there. Let's only look for these. 200, 200, 4301. When I'm actually using FUF and on my VPS, I have it set up automated so that I have a bash script where I can only just specify the target name, and I have a default configuration for FOF. Now, verbose default is false. Let's actually match -mc of those ones without the 405 ones. So nothing. There's something wrong with what I'm doing. 10.10.154.43. Let's try using derb. So derb http 10.10.154.43 / and then you need to specify the word list, then copy there, paste it there. Let's see. Maybe this is gonna give us better results. It was at M. Nothing at M. That's interesting. Nothing found. So what is wrong here? What is the Acme IT support website? Is it actually 10.10.154.43? It's not. What was the IP? Targeting the Acme IT support website, which is this URL will update 2 minutes from when you start the machine. I don't think it's been added to the etc hosts so that it says machine IP here. Let's look into the etc host. It's not in there. So I realized that I've actually made a rookie mistake here. I don't actually know how to use tryhackme. Now it says that you actually need to start using the machine. That's why I didn't. You have to start the machine from the first task. That's why I wasn't actually able to curl, or I wasn't actually able to see anything for my machine over here. So we're going to get the IP address in 1514. Can't believe I'm so freaking unaware of how everything works on tryhackme. This would be the command. Of course, we have another IP address, so it's not that one. It's not the actual address of the machine, but it's a different one, so 246. It's probably gonna find it, of course. It's gonna find a lot of stuff. So what was the question? The question was, what is the name of the directory beginning with mo? I said mobile. monthly. So monthly, like that. What is the name of the log file that was discovered? Development.log. There you go. So after doing a rookie mistake here on this, on actually knowing how to use tryhackme, this machine is this not machine, but what is this actually? Is it a scenario or is it a bunch of tasks? What's it called? This room, is it called a room? So this room is actually completed. Now up next, what is it that we're gonna have? Not content discovery, but subdomain enumeration. So yes,